Good morning, everyone. So, in the last lecture, we spoke about data transfer instructions of 8051. Now, here in this lecture, the focus will be to understand logical instructions of 8051. So, again, our objectives will remain same. The first thing what we would like to understand is the various mnemonics what are being available in 8051 for performing logical operations. Secondly, we will see their formats, like in what formats those mnemonics can be written. And we will also try to apply some examples on the instructions. So before I begin with logical instructions of 8051 in detail, let us try to accumulate the various logical instructions what we have in 8051. So as you can see here, the various logical instructions in 8051 starts from ANL. Now this ANL is the mnemonics for performing logical ending between two operands, right? The way we do logical ending using AND gate, the similar type of operation we can perform using ANL mnemonics, and AN is the operation that is ending operation on the content. Similar to that, we have ORL. So as the name itself implies, ORL is the mnemonics for performing the OR operation, logical OR, right? The way we use OR gate for adding two content, for making the logical ORing between two content, the similar way here you can do the logical ORing between two operands data. Next is XRL. So the XRL mnemonics is given for XORing operation. So as you might be knowing that we have XOR gate also. So the operation what is being performed by XOR gate, the similar operation can be performed by XRL mnemonics. Then next to that we have swap. Swap is to swap the content of two registers, right? So we will highlight the swap instruction using the example. Then you have rotate instructions, and the last what we will discuss in this lecture is complement, that is CPU. So moving on to the first mnemonics ANL, let us see the various formats in which we can write the instruction. So the first type of format here is ANL A, RN. That means this instruction when you write, it does the logical ending between accumulator's content and the register right from R0 to R7. So whatever, suppose if you have written ANL A, R0, then it is going to AND the content of A with R0's content, and the result will be stored into the destination register. So what is the destination register over here? If I consider this instruction, A is going to be the destination register. So the content of A will be ANDed with content of Rn, and the result is stored back into A register. Next to that you have ANL A, direct. So when I write this instruction, this direct word is used for internal RAM location number. So let's say if I write ANL A, 30 hex, the content of 30 hex internal RAM location will be ANDed with accumulator, and the result will be stored into accumulator back. Similar to that, you can write ANL instruction in the other formats also, like ANL A, @RI, ANL A, hash data. So when I write hash data, the data can be only 8-bit data. Why so? Because the accumulator is 8-bit. So at the most I can AND 8-bit data with accumulator's content. Then you can further write ANL mnemonics into the other two formats, ANL direct, A. Then you can also write ANL direct, hash data. So whenever I write direct word over here, direct means it is the address of internal RAM memory location. So here is an example. Let's say you have loaded accumulator with 00 hex, as it is written with red color. Move A with 00 hex. Then you want to AND the content of A with 25 hex, right? So how do you write that? ANL A comma hash 25 hex, and the result, what is going to be the result? Accumulator when it is containing 00 hex and when it is ended with 25 hex, the result is obviously going to be 0. So the final answer, which is 00 hex, that is again getting stored back into A register. Next to that, you have ORL mnemonics. Again, the same formats are applicable to ORL also. The only difference is ORL is the mnemonics that does the logical ORing between the source register and destination register. So here are the formats, and what we have changed is only this part. Earlier it was ANL, here it is ORL. So ORL is the basic mnemonics in 8051 that is used for performing the logical ORing between two contents. Next to that, here also the example remains same. The only thing what we have performed is the logical ORing between accumulator and the data 25 hex. See here, when I am loading accumulator with 00 hex and when I am ORing it with 25 hex, what do you expect in the result of ORing? 25 hex getting ORed with 00. So the result will be 25 hex, which is getting stored back into A register. Next to that, we have XRL mnemonics. So XRL mnemonics is again there for XORing operation. Now the worth noting point what you should have note down between ANL, ORL and XRL is the destination register is going to be accumulator, right? In the first four formats, the destination register is always accumulator. Can you see that? That means whether you do arithmetic operation or you do logical operation, in that when you want to specify the destination register has to be accumulator. You cannot write like XRL B comma RN, right? So that is something what is to be kept in mind. Then next to that we have swap instruction. So swap does what? It swaps the nibbles. So if I consider 8-bit data, 8-bit data has got two nibbles. The lower 4-bit is considered as lower nibble, and the higher 4-bit of the 8-bit data is considered as higher nibble. So what it does is the lower nibble that is being kept on higher nibble, and the higher nibble is kept on the lower nibble side. So let us see the example so that you get clarity on this. When I load accumulator with 43 hex and if I write swap A, then in the result what it does is 43 becomes 34. Now can you see that? 43, that is 3 is the lower nibble and 4 is the higher nibble. So 3 is getting placed into higher side and 4 is getting placed into lower nibble side. So that is what the function of swap instruction. Apart from that, I told you we have rotate instructions also. So there are two types of rotate, rotate towards left, rotate towards right. And the other two instructions are rotate towards right, rotate towards left through carry flag. Now what difference does it make is? When it is simple rotate towards right, You see that. RRA that stands for rotate towards right. RLA that is rotate towards left. That means what we are trying to rotate is the accumulator's content towards left or right. Now what it does in rotate towards right is, let us say any accumulator content you are holding an accumulator. In rotate towards right, the D0 bit gets shifted to D7, D7 gets shifted to D6, D6 gets shifted to D5, D5 gets shifted to D4, D4 gets shifted to D3, and the last is D1 which gets shifted to D0. Now when it is rotate towards left, the accumulator content what difference it is going to make is the D7 bit which is here, you see that, gets shifted to D0. D0 bit gets shifted to D1 and so on. Now if I talk about rotate accumulator towards right or left through carry, try to see the difference. In the earlier two format, there was not carry flag coming into the consideration. Now here what it is going to do is, when I do rotate towards right through carry, D0 bit is getting shifted to carry and carry flag status is getting shifted to D7. Earlier what was happening? D0 bit was getting shifted to D7 directly because it was rotated towards right without carry. Now when it is rotated towards right through carry, keep in mind D0 will go to carry and carry will go to D7. D7 will go to D6 and D1 again will go to D0. Alright? Similar to that, if you talk about RLC, that is rotate accumulator content towards left through carry. What is the difference? D7 bit is getting shifted to carry flag and the carry flag is getting shifted to D0 here. Right? So carry flag status is getting shifted to D0 bit. D0 bit will move on to D1. Then next to that, the last instruction, which is quite important in logical instruction, is CPL, that is complementing the content. So basically this instruction is used to invert the bits, right? So any bit which is holding all ones or combination of 1 and 0. So if you want to make 0 to 1 and 1 to 0, that is called as complement, right? So complement is simply, we can understand it as like complementing accumulator content is nothing but finding one's complement. So in one's complement, what do we do is whatever is 1 that gets converted into 0. So see here, when I load accumulator with some content, it gets complemented, right? So whatever position was holding 1, that will hold 0, right? So that is what we wanted to cover in logical instructions of 8051. In the next lecture, we will talk about Boolean instructions of 8051. Thank you so much.